Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region. This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat, and do this many, many times until we understand Europa globally.
Images from the Hubble Space Telescope tell us that Europa might be emitting plumes of water high into space. If so, a spacecraft could fly through those plumes and sample it directly to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth.
And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.
The Europa Clipper mission has passed preliminary development and strategy proposals and acquired further funding. The European Space Agency has been invited to develop an additional probe to ride along with the Clipper, as with the Cassini-Huygens mission, and either land or impact on the Moon's surface. The nominal Europa Clipper mission would perform 45 flybys of Europa at altitudes varying from 2,700 to 25 kilometers. A proposed launch window would be in 2025. If launched with NASA's new SLS heavy lift rocket system, the probe would take less than 2 years to reach Jupiter. Otherwise, it will be a 6.5-year flight. The largest moon in the solar system, and another icy world, is Ganymede. Composed of silicate rock and water ice, the surface is heavily pockmarked by impact craters and regions of tectonic movement. The moon has a thin atmosphere of oxygen and possibly ozone and atomic hydrogen. The moon has a liquid iron-rich outer core and an internal ocean with possibly more water than Earth's oceans. Most recent modeling suggests the interior may be layers of water and ice, like a club sandwich. Ganymede is also the only moon known to have a magnetic field. However, it is embedded within the powerful Jupiter magnetic field and overwhelmed. But there are indications of auroral activity on the moon. Ganymede is also the final target for the Jupiter Icy Moon Explorer, or JUICE, the ESA-designated mission to 3 of the Jovian moons. It will be launched in 2022 from Europe's spaceport in Kourou, French Guiana, on an Ariane 5, arriving at Jupiter in 2030 to spend at least 3 years making detailed observations. It will visit Callisto, the most heavily cratered object in the solar system, and will twice fly by Europa. Callisto is the fourth and most distant of the Jovian moons from Jupiter, and outside the main radiation belt of that planet. Unlike its sister moons, Callisto has a very thin atmosphere of carbon dioxide and molecular oxygen, and low radiation exposure. Callisto is composed of silicate rock and water ice, and may also harbour a subsurface ocean. It is considered the most environmentally acceptable location for a manned base in the future.